The MMCD infrastructure data standards represents a suite of standards that have been developed for infrastructure design, drawing production, construction, asset data exchange, and lifecycle management, with the bulk of these standards being built on AutoCAD Civil 3D. In this presentation, we're going to begin with a high-level overview of the MMCD infrastructure data standards. We'll then have a look at the development history. After that, we'll discuss infrastructure data as it applies to primary local government operations. We'll then get into a somewhat detailed review of the standardized components, these being the Municipal CAD standard, the Drawing Production standard, the Construction standard, the Asset Data Exchange standard, and the Asset Management Data Register. We'll then have a look at APEGBC certification, building information modeling. We'll quickly discuss standards adoption in the province, and we'll finish up with a discussion on future development plans for the MMCD infrastructure data standards. The MMCD infrastructure data standards suite addresses the design, drawing production, construction, record data collection, and lifecycle management process for local government infrastructure design processes. And in no way are these CAD standards related to MMCD construction specifications and contract documentation. That is to say that this suite of CAD standards can be implemented independent of the construction and contract documentation standards. Now, if we were to take the same diagram and picture this in terms of development, we have design, production, construction, record data collection, and lifecycle management. But the development hierarchy is all based on the Municipal CAD standard. So the Municipal CAD standard is essentially the drawing template for Civil 3D and all of the supporting files. And then the three subsets of that Municipal CAD standard are the Drawing Production standard, the Construction Modeling standard, and the Asset Data Exchange standard. So none of these three standards that you see on this intermediate tier can be developed without having the toolbox, if you will, which manifests itself as the Municipal CAD standard. And then for lifecycle management, we have the Asset Management Data Register, essentially a data schema for infrastructure data, and that can dictate the information that you would collect at the end of design and or construction phases of a project. So what you need to, the data and the attributes that you need to store will determine what you actually collect during the recording phase of the project. Let's have a look at the development history. So this all started back in 2009, and I was involved with, at the time, running a Civil 3D user group in Vancouver, and one of the issues that came up was the development of the drawing template. So Civil 3D 2009 was when the industry really started using Civil 3D. And the challenge was that all of the different local governments that consultants were working for had a broad range of standards and submission requirements. And Civil 3D is fairly demanding to set up from a standardization perspective. And so we kicked around all sorts of ideas on how do we address CAD standards when we have all of these different local governments that have a different set of not only CAD standards, but also drawing production standards. And many of the smaller local governments didn't have the capacity to create the CAD standard. So essentially they got what they got at the end of the project. And so that spawned the idea of developing a provincial CAD standard. And that's when MMCD published the first draft of the CAD standard. And I call this a feeler standard just to gauge the level of interest. So we announced this standard and held a meeting at BCIT on a Wednesday night. And I think it was about 80 or 90 people came out to that meeting. And at that point, we knew we were onto something. So things really kicked into gear in 2011. And the District of Saanich on Vancouver Island wanted to evolve this municipal CAD standard. They got the idea of the benefits of having a provincial CAD standard. So I worked with them directly to evolve that standard, and that in turn became the first real substantial release of the CAD standard. So we took this light version of the standard and evolved this heavily based on the District of Saanich. And that's when was essentially the first major update to the CAD standard. In 2012, we introduced the Asset Management Data Register, and that was really in response to the TCA requirements, Tangible Capital Assets, the PSAP 3150 accounting standard. And this brought attention to the attribution required for life cycle management. And then in 2015, the City of Burnaby needed this asset data exchange standard. So once again, we put that together for them, and that rolled back into the MMCD asset data exchange standard. And this was all developed for the submission of attributes on the infrastructure assets at the end of the design and construction phases for a project. And that essentially involved object data tables, map 3D object data tables. And then coupled with that is the need for consistency in drawing production. And so in 2016, the City of Burnaby developed the drawing production standard, and then we rolled that back into the MMCD suite of standards. Let's discuss the development history of the MMCD infrastructure data standards. So Civil 3D 2009 was really the first release that consultants really started embracing the technology, and the feature set was built out. The bugs were built out, and it really became a viable application for infrastructure design. And at the time, I was helping coordinate the Vancouver area Civil 3D user group. And one of the challenges that presented itself was the fact that the consultants were working for many different local governments across the province, and everybody was maintaining their own set of CAD standards and drawing production standards. And as you know, to set up a Civil 3D drawing template to address those standards is quite a laborious and time-consuming process. And we kicked around all sorts of ideas as to how to address that. And at that point, the idea of developing a true provincial CAD standard was spawned. And what better place to host this standard than MMCD? So when I approached MMCD, we put out what I would call a feeler or a light version of the municipal CAD standard, and didn't want to put a lot of effort into it at that point. Just wanted to see how it would take. And so we then had a meeting at BCIT on a Wednesday night, and about 80 people came out to this meeting. So we knew we were onto something. People really, I think the local governments were feeling the pain of inconsistent submissions. The consultants were feeling the pain of having to change gears every time they worked for a different local government. And the contractors were feeling the pain because drawing production and specifications were all different based on where you worked. And so the next big leap was in 2011, where District of Saanich really wanted to get on top of this. And so we evolved the MMCD Municipal CAD Standard to quite a high level for Civil 3D 2011. And that then rolled back into the MMCD Municipal CAD Standard. The Asset Management Data Register was launched in 2012, and essentially this was in response to Tangible Capital Assets requirements and the PSAP 3150 accounting standard. And really what this did was bring attention to the attribution required for life cycle management of infrastructure. In 2015, the City of Burnaby needed to implement the Asset Data Exchange Standard. So at this time, we had that standard on the radar, but we hadn't developed it yet. And so I worked closely with the City of Burnaby to develop this asset data exchange standard, and that then was rolled back into the MMCD standard. This is based on MAP 3D object data tables, and it brings consistency to infrastructure asset attribution for post-design and post-construction submissions back to the local government. And the idea is that with this asset data exchange standard, this is a kind of a sole source deliverable from the consultants to the local government so that they can move that data, if you will, directly to their asset registers or their GIS systems. And then following that in 2016, with the City of Burnaby, we developed a drawing production standard, and the whole intent of this was to bring consistency to how a drawing set looks. And that, once again, would manifest itself in benefits to design processes, drawing review processes, and construction processes across the province. When we look at infrastructure data and local governments, you have ideally the asset register. That's your infrastructure database. We'll talk about that in a moment. And we design, we produce, we construct, and record. So from the asset register, you can develop your capital plan. So through asset management practices, we can contribute to the development of the capital plan based on the needs. A project would go through a preliminary design, a topographic survey, a detailed design, construction, the collection of that record data, the reduction of that record data, and then the movement of that data back to the asset register. And at various points through the life cycle, or through the project phases, I should say, we can move information back or extract information from to and from the asset register. And after construction, that data has been moved back to the asset register, and we can begin our life cycle management practices where we consider the condition, the remaining life. We can do our operational maintenance planning, capital planning, and develop financing and funding strategies for our infrastructure. Now, when we consider a local government asset register and the functions of a local government, as it turns out, most primary local government functions have a vested interest in infrastructure data. So you can see that we have asset data consumers, the red arrows, and asset data creators and consumers. So everything from emergency services, finance, environmental services, parks, transportation, stormwater, sanitary, licensing and permitting, buildings, public works, planning and development. So this really is something that, in my opinion, we really need to get on top of, because it's all about sustainable infrastructure data management. And when you have such a large group of individuals and roles within an organization that have a vested interest in working with infrastructure data, it's important that we institute best practices for data management. Now, the asset register, ideally centralized data storage or a set of relational database, but the key is unique IDs and processes. So what we don't want to have is different divisions within an organization maintaining their own attributes and own information on the same asset. So ideally, the pie in the sky is an open database, spatial database that various systems have read-write access to. Obviously, that's a complicated thing to set up. The next step is a series of relational databases where a unique ID for all of these assets is maintained. And with that, you need good processes and good communication. But we definitely need to strive to move away from our own independent databases on the same infrastructure assets. Let's have a look at the MMCD Municipal CAD standard. So this is essentially the drawing template and all the supporting files, and it's the highest level of the hierarchy. So it's a toolbox for design, modeling, and drawing production. It consists of AutoCAD standardized components. So when we put this together, the first step was to develop a solid base of AutoCAD standards based on the national CAD standard, the layer names. We wanted good block definitions with good naming conventions, a set of text, dimension, and multi-leader styles, page setup and layout definitions and system variables. So that is the base AutoCAD standard. And once you have a good solid base AutoCAD standard, you can build on that the Civil 3D standardized components. So those will include items like the drawing, feature, and command settings in Civil 3D. What they do is they assign default styles for commands. They assign default names to objects. So we can now start thinking about standardized object names for alignments and profiles and surfaces, and also command-specific parameters. So for example, when you create a corridor model in Civil 3D, what is the default assembly insertion frequency? So those are the drawing, command, and feature settings. You also have a collection of object styles which control the display of objects, and label styles which control the display of the annotation. And now the user doesn't need to think about what layer and alignment goes on. You choose the alignment object style. If it's a proposed pavement edge or if it's a proposed center line, that object style will display based on the standard requirement. The same goes for the label style. So with object and label styles in Civil 3D, your design will result in automated drawing production. So drawing production is a byproduct of the design process. The other Civil 3D standardized components include survey codes, description keys, and point group definitions, and also a figure prefix database that automates the assignment of existing line work to layers and break line toggles. And as I mentioned earlier, the MMCD Municipal CAD standard manifests itself in the Civil 3D drawing template and the supporting files. So those would be SHX files, plotting files, line type files, and so forth. Now, the MMCD Municipal CAD standard does not incorporate drawing, appearance, or data structure. So this is where we start thinking about submissions. In the past, the submission was emphasizing the plan profile drawing. And a digital submission doesn't need to be the plan profile drawing. It's the design model drawing that contains all the data. So that is the data structure, and then you have the drawing appearance. Well, basically what that means is that we have this toolbox of tools, which is the MMCD Municipal CAD standard, and you can give 10 designers that same toolbox and ask them to produce a design for the exact same project, and pretty much guaranteed that the way the information is presented on a drawing is going to be different. And so that really spawned the need for a drawing production standard. And so this is the drawing production standard here for design and construction drawings. This is a subset of the Municipal CAD standard. And really what this does is it brings consistency to drawing appearance. So plan, profile, view, orientation. There's plan on the top, is profile on the bottom. What are the scales? What AutoCAD text styles and heights are we using? How do the blocks look? What layers and line types, line weights and line types? Data callouts, the nature of the callouts. How do we annotate elevations on a manhole? How do we show our standard notes? And then obviously the Civil 3D and object and label styles can bring consistency to that. And then there's obviously the consistency with which drawings make up a drawing set. So the idea is that if you're working for Burnaby or New West or Coquitlam or Prince George, the way the information is presented in these infrastructure drawings is consistent. And that certainly benefits designers, reviewers, and contractors. The MMCD construction modeling standard is also a subset of the design standard, and it presented itself as an issue because as time goes on, more and more contractors are wanting the data. And this actually presented itself a bunch of years ago, and a client of mine called me up and said, Andrew, I'm very concerned. The contractors are asking for the data, but we all know there's a big gap between, or potential gap between, what actually appears on the signed and sealed engineering drawings and what's physically designed modeled in the database, in the Civil 3D database itself, which is essentially a collection of drawings. So we thought that there should be a construction modeling standard which basically outlines the requirements for data that's going to be used for construction layout, quantity calculations, construction staking data, and design analysis. And that's what your construction model is used for. So we need to consider things like level of development for construction modeling. And much of this has been occurring in the building industry with BIM, if you will, level of development, level of detail, but not so much in the infrastructure industry. So essentially, when you have a surface, what are the minimum requirements for a proposed surface that will result in proper construction staking and layout practices, given that we're using digital data? So things like corridor assembly insertion frequency and surface modeling standards. Also, the component consistency required for construction modeling. Are we using alignments? And how are we using alignments and profiles? How are we using surfaces? And how are we using cross-section data? This opens up an issue with regards to data certification. And, we are not there yet, obviously, in the industry, but at some point in the future, we will not be using paper, and all of our design model data will be moved to construction machinery, and we need to be able to certify that data. Incidentally, Florida DOT has developed some tools for certification of data, and we're also looking at that in conjunction with the BC Ministry of Transportation Civil 3D implementation project. Now, this standard has not been completed, but it definitely is on the radar as something that we need to develop to round out the suite of the MMCD infrastructure data standards. The Asset Data Exchange Standard. So once again, life cycle management is all about having information on your assets. And once again, the best time to collect that information is at the time of commissioning. So when the project is being designed, that's when we submit the data. And if we look at the Asset Data Exchange Standard, it's essentially a bunch of object data tables in Civil 3D. The object data table is a map 3D function, which is part of Civil 3D, and it describes features and attributes. So we have standardized feature names, standardized attribute names and values, and once again, based on AutoCAD map 3D object tables, data tables. So these are in the drawing template, and the designers would be required to populate these object data tables and attach that information to the assets in the design drawing. So it does pertain to local government submissions, and there are 4 components of the standard: existing recorded assets, survey recorded assets, design recorded assets, and construction recorded assets. And as you can see on the diagrams here, much of the data can be attached using the AutoCAD properties palette. The Asset Data Exchange Standard also considers scale factors. So contractors and construction practices are typically based on ground level coordinates, whereas in a local government asset data register, a GIS, we are dealing with UTM coordinates. And so we've also addressed the scale factors as part of the Asset Data Exchange Standard. So when we consider the Asset Data Exchange Standard, we talked about the features and attributes and the local government submission. So existing recorded assets, I'm going to describe what's going on with Burnaby here. So what the city of Burnaby does is, from their Esri GIS, they will use Safe Software FME to extract information. And essentially, you window the area of the project and an AutoCAD drawing will be created. And that's created to the MMCD CAD standard. And all the layers are an R for a prefix as opposed to a C or a V. And the R stands for recorded. So the layer prefix varies, and a drawing is produced that shows all of the existing conditions, so the information that the city has on all of their assets in the project area. And also, all of those assets, the pipes and the structures, will have a map 3D object data table that contains all of the attributes as per the Asset Data Exchange Standard. So the asset attributes that you're actually tracking. And one of those attributes is the life cycle status. So the existing recorded assets drawing is provided to the designer. The designer would then update that drawing to change the life cycle status of the assets that are affected by the project. So 70 to 80% of Burnaby's capital program is to replace aging infrastructure that's at the end of its useful life. And we need to identify the assets that have been retired, abandoned, improved, removed as part of that project. And that's the intent of existing recorded assets. Survey recorded assets. So you'd obviously be conducting a GPS, a total station survey in advance of your project. Well, we're going to be collecting data that goes beyond where you're constructing, and you're going to be collecting data on assets that won't be affected by your infrastructure. And you can use the survey data to validate the existence and location of your infrastructure assets. Design recorded assets. So there's a need to get the data on the books, so to say, at the IFT issued for tender stage of a project. And then that would be copied, that drawing, the design model drawing, would be copied to construction recorded assets, which is updated to reflect as constructed conditions. As I mentioned earlier, we need to consider scale factors, once again, because construction is based on ground level coordinates, and local governments want to store information that is coordinated to a UTM or a grid zone. And one of the big impacts to the designers is the data structure. So I was mentioning the plan profile drawings as a historical emphasis for submissions. Well, now what we're doing is we're saying, let's create a design model drawing that contains all of your design, and then using the Civil 3D data shortcuts, reference objects, and AutoCAD XREFs, you can create a separate set of production drawings that source the data from the design model drawings. And it's this design model drawing that contains all of the data and all of the attribution. And that's what would be submitted to the local government upon completion of the project. The Asset Management Data Register was developed in response to TCA and PSAB 3150, and this brings attention to the life cycle attributes required for infrastructure management and financial reporting as per the accounting standard. So essentially it's groups, subgroups, type, subtypes, and attributes. It includes the engineering properties. So these would be your elevations, grades, slopes, diameters, as well as life cycle management attributes. And as part of this, we developed an infrastructure data manager in Microsoft Access, which is essentially a standalone data manager that mimics IPWA NAM's Practice Note 4 for small communities. So we have a lot of small First Nation bands and local governments in the province that don't have access to these sophisticated systems. And this was a tool that envelops the data schema that can be used for lifecycle management. And APEGBC is behind record drawing certification, but we haven't once again gotten into record data certification. So that becomes really important when we're obviously moving information to the field for construction, as well as because decisions are being made based on the attribution and the data submitted, we need to make sure that that data is correct, and that will come in due time. Just a quick slide on BIM, Building Information Modeling. This is an industry term, a practice that really is encompassing what it is that we're doing here with MMCD. It's all about design modeling. And I wrote a few articles over the last couple of years to try to characterize BIM as it relates to infrastructure. Once again, there's lots of information relating to building and architectural and structural work, but not so much on infrastructure. And so really it applies to the movement of data throughout process adjacent phases. So, preliminary layout information should be handed to the designers for detailed design rather than recreate the geometry. We move the information from design to construction. We collect the information from construction, and then we move that back to the asset register. So that's one aspect of BIM. We discussed sharing data between design team members. So rather than duplicating data, we create the design model drawing, and then we share that into our production drawings using reference objects for Civil 3D and XREFs for AutoCAD. And then obviously the life cycle management. And at this point, this isn't Civil 3D. So Civil 3D is the vehicle to get the data to your asset register, but BIM as it relates to infrastructure is definitely about life cycle management. So those three areas are how I see BIM as it relates to infrastructure data. So we've had obviously great uptake. These are just a few examples of some of the local governments that have adopted to varying levels the MMCD infrastructure data standards. I know there's lots more. Many projects are referencing the MMCD infrastructure data standards for non-municipal organizations. And I think we're really on the cusp of moving to the next level with all of this, just because the emphasis these days is on the data, and we're providing the tools to be able to do that. For future direction, we're currently amidst an update to the MMCD Municipal CAD standard to bring this to the Civil 3D 2018 platform. We're going to be engaging the community to ensure that we solicit information that will help us evolve this standard. Other things that we want to do is develop an install package that would create an AutoCAD profile that would have all the settings for the standard, including tool palettes. We want to develop custom sub-assemblies and assemblies that meet MMCD specifications. We need to evolve the Gravity Pipe Network catalog. And also in 2018, we're now going to have full support for pressure network catalogs. So we'd like to do that. And another area that we'd like to improve on is object data tables is old technology for asset attribution. That was in fact developed in the late 80s, early 90s by a company out of Edmonton called Canotech, which Autodesk acquired that technology. And we'd like to now move to the new AutoCAD property sets, which give us much more flexibility for attribution. I think it's also important that we look at tightening the relationship between MMCD specs and the CAD standard. We just started up an asset management subcommittee where we've got industry representation to get better ideas and collaborate and present directly to the board on the needs of these infrastructure data standards. As I mentioned, we need to develop the construction modeling standard, and the AMDR is in need of an update as well. So lots of things on the table that we can accomplish. So that concludes the overview of the MMCD infrastructure data standards. My name is Andrew Walter. If you would like some more information or would like to follow up, please feel free to contact me anytime. Thank you very much.